So of course we can get isomers, and again we have to try to keep these different kinds of isomers straight in our minds. Functional group isomers. Okay, so these are compounds, same number of carbon atoms, same number of hydrogens, oxygens. They have this, isomers always have the same molecular formula. But the functional group isomer are going to have different functional groups. And so here we can see this is an ester, and this is a carboxylic acid. And so by moving this COO thing to the end, then we get a carboxylic acid. Scooting it over into the middle, now it's a different functional group. It's an ester. So these are functional group isomers, because one's an ester and one's a carboxylic acid. We can have skeletal isomers, and both carboxylic acids and esters exhibit skeletal isomerism. And this is where you've got differences in these alkyl chains, these carbon chains that are attached to the business part. So here we've got pentane, pentanoic acid, and we've got a straight chain, and here we've got a branched chain, and so that's an isomer. It's a skeletal isomer. It differs in how the carbon chain is arranged. And then we have positional isomers. Carboxylic acids don't have positional isomers because that carboxyl group has to be on the end, just like the aldehydes. The aldehydes don't have positional isomers. The aldehyde group is always on the end, but ketones can move around. Esters can also move around. And so here's the ester, and we can have this group in the middle with a methyl on one side and an ethyl on the other. Here it's methyl propanoate, or we can scoot it over one carbon, and now this is ethyl ethanoate. And one way you can identify these positional isomers especially is to name them. If you name them correctly and come up with the same name, then it's just the identical compound. If you come up with a different name and both of those names are correct, then you have isomers. So these are both esters. Positional isomer, the functional group stays the same, it just varies in its position. A functional group isomer, you're getting different functional groups. And so this is a carboxylic acid, and this is an ester, and so they're named completely differently. And the skeletal isomers just differ in how the carbon chains are arranged or branched. Any questions?